Hello everybody, I will start my today's another live coding session. So in my today's video, I will solve this question. Cut off trees for golf event. You were asked to cut off all trees in a forest for a golf event. The forest is represented as an m by n matrix. In this matrix, 0 means a cell cannot be walked through. 1 represents an empty cell that can be walked through. A number greater than 1 represents a tree in a cell that can be walked through. I can walk through the tree, okay. And this number is the tree's height. In one step, you can walk in any of the 4 directions, north, east, south, and west. If you're standing in a cell with a tree, you can choose whether to cut it off. Yep. If I'm standing in a cell with a tree, I can choose whether to cut it off or not. Okay. You must cut off the trees in order from shortest to tallest. When you cut off a tree, the value of its cell becomes 1. An empty cell. Starting from the point 0, 0 returns the minimum steps you need to walk to cut off all the trees. If you cannot cut off all the trees, return -1. The input is generated such that no 2 trees have the same height. And there is at least 1 tree needs to be cut off. Okay. So let me understand this question first. So in this question, I will be given the matrix n by n, and the input should be the integer, which represents the minimum steps I need to walk to cut off the trees, or maybe -1 if I cannot do that. So that's the input and output, and the task, what to do, in this question is, I start from 0, 0, and I try to cut all the trees. And when I walk through the tree, I can walk on any cell aside from 0, 1 or 2 or 3 or 4, 100 or anything. And when I walk through, say, tree 2 or 3, which is larger than 1, I have 2 choices: to cut it or not to cut it. In that case, if I don't cut it at the time, I have to come back to cut the tree again. And I have to cut the trees in ascending order in terms of the height. Yep. Okay. And for 0, 0, maybe this could be, I don't know, 1 or maybe 0. I don't know if it's possible or not. Yeah. Probably this is not 0. I think this is what I can clarify in the actual interviews. But anyway, I will try to, walk around the cells to cut off the trees in ascending order. Going back is accepted in my understanding. Okay. Yes. Okay, so that's what I will do. So let me think with some example. So in this case, what I will do is, firstly, I go to 1, then 2, then 5. So because I have to cut the trees in this order, 1, 2, 3, 4, 5, 8. Let me change it to 6 and 9. So if I start from 0, 0, I can go through 5, but I don't cut it now. I go to 1, 2, and then I go until 3 via 5, 4, 7, 6, 3. Then I go to 4 via 6, 7, 4. Then I go back to 5. Then I go to 6 via 4, 7, 6, and then go to 7. So I don't know how many steps I took, but that number of steps I've taken so far is something I should return. Good. So that being said, let me think of this question. So in this case, all the trees are sorted. Oh, I mean, sorry. It's there 1, 2, 3, 4, 5, 6, 7. All numbers in a row. I mean, consecutive numbers. It was easy to understand. But for example, if this is 55 or if this is 42, in that case, it not intuitively, I mean, I cannot say which cells I should visit first. Probably I can replace them first. So, for example, if I have 3, 1, 2, 5. Okay, so I will list all the height, which are not 0, and sort them. Oh, I don't include 1. Then I sort this. In this way. Then I put the index like this. So in this way, I can know in which order I should visit each cells, which is larger than 2 or equal to 2. So I think that's something I can say first. So for example, in this case, 0, 0 is exactly cell 0, 1. Then cell 3 is 2, 0. Then cell 4 is 1, 2. Then cell 5 is 0, 2. In that way. So that's what I can find first. And obviously from here, what I can do is find the shortest path, which goes through 0 or 1 or something which has already been cut. So maybe I can do the breadth first search for that. Yep. I think that's what I can do to find as a path for each cell to cell step. Okay. So I'm not sure this is a good enough in terms of the time complexity. Yeah. It's 50 by 50 cells. So theoretically, I have 50 steps from cell to cell. Sorry, 2,500 steps, or I should say transitions. And for each, I don't know how much time it will take, but I will use the BFS, so it took some time. Yeah, so that's what I can say. So I will think how we can optimize this. So obviously this is a brute force approach. So firstly, I can say, I think, I don't know, it is, efficient to do BFS from step to step. Maybe I can do all of them in, one step. So, sorry, one operation. So I think I know that there is a kind of algorithm I can use to find the shortest path between each cell to each cell. If my understanding is correct, maybe I'm wrong, but I think there is a kind of that algorithm. Maybe that's something I can think. Or aside from that, mm, okay, so let me think it with a chart. So let's say I have to visit them in this order. And I will think that all the cells X are not visitable, and all the cells O are possible to visit now. In this case, so I start from here, and first I visit this, and this, and this, and this. But so one thing I'm wondering is, for example, say if one is here, I will change my mind. If one is here, when I do from this 3 to 4, there is a cell I cannot visit first, but when I visit 1 and then come back to 2, then when I visit 3, and after that, now this 1 is visitable. So what I can say is, for cell-to-cell transition, all the cells which are smaller than the start index, are visitable. I don't have to take care this is index 1 or index 2 or originally 1. Yeah. Because all of them are represented, I can visit them. Okay. Mhm. So I start from here and visit here, then come back and visit here, and then here and here. Mm. So okay. So as I said, I think I can use BFS, but still I have to do it for each cell to cell, for index 1 to 2, then 2 to 3, and 3 to 4, which are not so efficient, I think. So let me think how we can optimize this. Mm. Yeah. Okay. So let me stop my video and I will search for the shortest path algorithm for each cell to cell. If my understanding is correct, I mean, if my memory is correct, there is an algorithm that I can use to find the shortest path for each pair of the cells. So let me search it and come back. Okay, so I've searched something. So now I remember that this is my node, but let me. Yeah, okay. So I could find Floyd-Warshaw's algorithm, which calculates all pairs shortest path algorithm, but it takes v cubed. V is the vertices, number of vertices. So in this case, I have, 50 by 50. So this means that up to 2,500 vertices. The 2,500 vertices cubed is more than 10 to the power 10. So probably this doesn't work. It takes too much time. So let me think of another algorithm I can use. And again, if I use the BFS, there are 2,500 transitions, and it will take up to V plus E transitions at max. So it's not so efficient. Okay. Mm. So if I start from here, then go to here, 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 here. Let me think a bit more. So so mm, if I start from here, 1, 2, 3, 4, 5, 6, 7. Okay. So if I think that I I'm thinking if you can use the topological sort now, because the order is decided, and what I'm looking for is the shortest path to visit all the nodes with, I mean, satisfying these orders. Hmm. No, topological sort just finds the way. It isn't, necessarily be the. It isn't necessarily the shortest path. Okay. Okay, so let me implement this brute force approach. So step by step, I do BFS. So let me sort out my approach, and I will implement it. Then I will optimize it if it doesn't work. I mean, it doesn't. It is TRE. Okay. So first thing I will do is sort auth to plus cells to find visit order. Then for each step, do BFS to find the shortest path. Then I will return the total steps. Good. So this is what I will do. Okay. So I will implement. So number 1, I will try to find all the list of cells in order to be visited. So it seems like this one. Okay. So let me do it in this way. Oh, by the way, no two trees have the same height. Yes. So I can always find the way to visit all the trees in ascending order. So this is the height. Okay. Now I will sort them. Okay, so now let me move it into another sub method. Okay, so this is it. So this is, yeah, trees to visit. Okay, so this is all the tree cells. So the next thing I will do is try to visit cell to cell and find the path ranks from cell to cell. So show test path ranks. So I will start from 0, 0. So yep, then prep cell should be cell. Okay, and I increment total path ranks with this. Then I will return this total path ranks. But the one thing I have to take care is if shortest path ranks is not possible, sorry, if it isn't possible to visit from previous cell to the given cell, I have to return -1. In that case, let's return -1, sorry, none if not visitable. Yeah. In that case, I have to return -1 immediately. Yep. So this is it. Good. So now my task is to implement this one, shortest path ranks. So I will visit from start to end. And as I said, I will do the BFS. So Q is deck and path rank is start from 0. Okay. Good. So obviously start should not be end. Okay. So from here, I will just do the, typical BFS. Okay, so I can find it in this way. By the way, this doesn't have to be here, but it should be here. Okay. So I will try to visit this current row, current column, but obviously I have to do some filtering here, or I should say validation here. So firstly, I have to check current row. I mean, this cell is not, I mean, this is in cell, and also this is not visited yet. And also this cell is not 0. I mean, it should be value of this cell should be 1 until third cell bar. Yep. So these are the conditions I have to check. Otherwise, I cannot go through this cell. And also, as I said here, I have to keep track of the visited cells. Let me add it here. Okay. This is it. And if not visited yet, so I will return, I will continue, so I will check it. Then I will check if this current cell meets this range. Start cell bar. So forest. So if this is not true, I will continue. Okay. Now I can visit this current cell, current row, current column. So I will check if this is end cell, I can return path length. Otherwise, I will put this into the queue and also this mark this cell as visited. Yep. Then finally, I will return -1 here in the end because reaching here means that I couldn't visit the end cell. Yeah. Oh, what I'm doing here. Yep. Looks good. Let me, submit my code. So today I don't do the dry run because I will probably have to take so much time on optimization, but probably I should do the, dry run. get all the trees, append trees is not initiated. Good. This should be tuple. Q.pop left, previous column. Doesn't work. What's it? Let me print out what is in the queue. Hmm. 0, 0. Okay. Ah, I see. So this should be list of start. Okay, so seems like there is an error. Somehow, I see. I should return none instead of -1. Okay, now I've got -1, -1, -1 all the time. Probably there's a problem in this shortest path length method. So let me check it. If I try to visit 0, 0 to 1, 0, oh, wait, why do I have to visit this 0? Oh, this service is a problem. So I see. In the get all the tree cells method, I have to skip tree whose height is 0 or 1. Here, I have to do this. Now what happens is that the assertion error. So let me print out what in the trees list. Or maybe I will print out this. So 0, 0, yes, 0, 1, 0, 2, 1, 2, 2, 2, 2, 1, 2, 0. Yeah, this seems good. Probably this get all the trees cells method is implemented correctly. And for this all the tree cells, I see. Now this includes this 0, 0. So this 0, 0 can be 0 or 1 or 2 or maybe 3. But let me see. Okay, so what I can do is if path is equal to end, I can return 0. Yeah. And also, I think still there is a probability that I cannot visit from 0, 0 to this start cell. In the yeah, but it's covered, or let's just say filtered out in this continue, especially in line 60 to 63. Okay. So where is it? So the problem here is I got some path ranks -1. I mean none. So let me print. previous cell and current cell to see what's happening here. So in this case, 0, 0 to 0, 1. Only that. From 0, 0 to 0, 1, I return -1, but obviously I can find the path. What's going wrong with this? Mm. And in line 56, I'm checking if this is in the cell. Yes. And I will check if not visited yet. Yep, good. And I will check if this means the condition 1 until start. Yeah, I think this is good. Yeah. So if current row is equal to current column, end, it should return path ranks. So let me check. I can say yes in cell, and here, yes, not visited yet. And here I can say yes, visitable height. And it says yes, yes, yes. And oh, I will print out this. What's happening here? 0, 0, 0, 1. I think nothing is printed here. Sorry. Here, yes, visitable height is not printed yet. So that's a problem. So start cell height should be 1, yes. And no. Yes, true, yes. Start cell height. What I'm doing here, start cell height is 1, and current row, current column. Wait, so, but now current row, current column, what is it? So I start with 1, 0. Oh, no, sorry. Current row. So, wait a minute. So I start from 0, 0. Wait. I'm talking about 0, 0 to 0, 1. Yes. So start cell is 0, 0. So start height should be this, which is 1. So it says there is no height which is visible. Sorry, so it has to be current cell is equal to 1 or smaller or equal to start cell. Mm. But I'm a bit wondering why it happens, because current or current column should not be the start cell. It should be now 1, 0, which is, sorry, it's 1, 0. It should be 0. This should be, you know, not visible. Yeah. Hmm? So it's okay. Yes. So here, when I'm talking about 0, 1, for 0, 1, this should be visible because this is 2. I see. So I find the reason why. So this check is too strict. I have to do it until end cell height, because end cell height is something I can visit in this, BFS. And also this end cell height is exactly what I'd like to reach in the end. So I can remain, leave this. Good. Okay. Let me execute my code. Wrong answer. 2. Again, I will print out. So I should visit in this order. So from 0, 0 to 0, 2, I couldn't visit somehow. Mm. Let me print this out. Okay, so if I start from this cell, I can start from here and I'd like to visit 2, 0. No? Oh no. But in this case, I cannot visit. Yeah. Ah, There's a misunderstanding. I can visit any cell here in line 70 as long as it registers a 1. But I just don't cut it. Yeah. So I can completely forget this. So if forest height is 0, I cannot visit it. Otherwise, I can visit it. Sorry, so if this is equal to 0, I will continue. Good. Okay. Oh, accepted. Wow. It worked. Great. So, okay. I thought this is a kind of brute force approach, but it worked. So in this question, okay, I will quickly wrap up. So in this question, I was given the board of 3 heights. For 0, I can visit the cell. For 1, there is no tree and they can visit it. And for other trees, other cells, like 2 or larger cell numbers, it signifies the tree height. And I will start from 0, 0, and I will try to visit all trees so that height of the trees are in ascending order. Okay, so in this question, I solved it in this way. So I firstly sort all the trees to be an ascending order. I mean, so that I can find the visiting order. And then I will think of every transition from 0, 0 to next cell and next cell in a sorted way. And for each transition, I use BFS to find the shortest path. And I return the total path length. Yep. And something I had to take care is in line 46 and 47, if start 0 is equal to end 0, I should return 0. So this happens when the first cell is 0, 0. In that case, it doesn't take any cost from move from 0, 0 to 0, 0. So I can return 0. But otherwise, for example, 0, 0 has 3, but it isn't the shortest tree height. In that case, I have to do the BFS to find 0, 0 to the shortest path. And I will visit the 0, 0, 0 later again. Okay, good. So for the time complexity, let me quickly tell it. So Mn is the number of cells. So firstly, I sorted them. This takes Mn log Mn. Then after that, I did the BFS for each transition, and there are Mn transition. And for each, I did the BFS. In the worst case, it takes V plus E, time complexity. V is the number of nodes, and E is the number of edges. So for edges, vertices, there are Mn. Edges, it almost like Mn times 2. Because when I think of the vertical edges in one row, there are, n edges. Yep. And there are m rows, so it'd be nm. And for vertical edges, there should be, you know, yeah, there n, sorry, m edges in one row, and there are n columns, so it should be mn. Also, not enough. Also, because they're bidirectional, each edge is bidirectional, I have to multiply 2, so it should be 2 to the 4 mn. So it should be mn plus 4 mn. So in the end, this takes mn cubed. Yep. And for space complexity, probably I could use this one, Floyd-Warshaw's algorithm for this, because this is mn cubed, and this Floyd-Warshaw's algorithm also takes v cubed, which is mn cubed in this case. So yeah, probably I could use the Floyd-Warshaw's algorithm, but it's okay. And for space complexity, I did the sorting, which takes mn, because in the Python, it uses the temp sort internally for sort function, and it takes linear extra space. And aside from that, I use the Q in the BFS, and also visited set. Yeah. So for Q, how many cells could be in each Q? So yeah, let me think of visited set first. This takes mn cells. In the case I have to I have to check all the cells, almost all the cells to be visited in the this cell. And for Q, let me write it down. So the board should look like this. And I would say in the first visit, I can visit this. And second, I can visit this. Third, I can visit this way. Yeah. And fourth, I can visit in this way. And fifth iteration, I can visit these cells. And sixth, I visit here. So I can think these, cells with the same number can be in this queue at the same time. Or I should say, if I visit this and this and this, I pop out this, then I append this and this, or like that. But I can say it almost like the number. Number element, the queue is the number of the same numbers, number of cells with the same number at the same time. Yeah. So I can say it should be minimum mn. Okay. So for space complexity, O of mn takes first, but after that, it doesn't cost. And for Q and visited, this is necessary for each BFS. So I don't have to, get the sum of these Q and visited for each BFS. Only the maximum Q and visited space in any of the, BFS, shortest path length call, should be the space complexity. It should be this. Let me write it or here. Okay. So it should be all of MN. Okay, good. This is the space complexity. Okay, that being said, I finished my today's coding practice. Thank you so much. Bye.